Okay, so let's work that problem I just did for CO2. Okay, so we want to know the percent by mass of carbon and oxygen. So it doesn't matter what our size sample is because it's fixed by this C to 2O ratio. We can choose any amount to determine the percent by mass because it's always going to be the same whether we have 10 grams, 100 grams, 1,000 grams. So the easy one to take here is, let's just say we have 1 mole. And 1 mole is easy because if we have 1 mole of CO2, we know that the molecular weight is going to be 12 grams, well, it's 12.01 grams of carbon plus our 16.00 grams plus 16.00, I'm out of space there, grams. That means the molecular weight is equal to 32 plus 34, it's 44.01 grams per mole. So if we choose as our sample size 1 mole, we're going to figure out how much carbon, so percent carbon by mass is going to be equal to the grams of 1 mole of carbon over 1 mole of CO2, 44.01 grams, and our percent mass of the oxygen is going to be equal to the grams in now 2 moles, right? Because there are 2 of those atoms of oxygen, 2 moles of O for every 44.01. See, it's fixed by the formula. So in this case, this becomes 12.01 grams per mole divided by 44.01 grams per mole. And remember, times 100%. And this one is going to be 16 plus 16, or 32.00 grams per mole divided by 44.01 grams. No, it's just 44. Yeah, 44.01 grams per mole. Again, that's times 100%. So the units cancel, and we're left with this unitless percent. And that's it. That is percent by mass. And that's no matter what your sample size is, whether we're talking about 10 grams, 100 grams, 1 million grams, it's always going to have the same ratio because it's fixed by the formula. And that's the key concept, that the number of atoms in a molecule fix the mass of each atom, and therefore fix the ratio, the mass ratio in that molecule. And that is percent by mass. And then we're going to use that in a variety of ways. But it works for molecules really well, but it works for anything. It could be percent females in our Chem 111, percent males. It could be percent redheads. It could be anything, right? It's really related to the number of those, in this case, atoms in a sample. And if we choose 1 mole, we know what the mass of each of those mole of atoms weighs, and it makes the calculation quite straightforward and simple.